In this question we have a cow that weighs 300 kilograms, and every day that goes by the cow gains 6 kilograms. So beef is currently selling at $2.70 per kilogram, but the price is dropping 3 cents per day. So we can see that on one hand the cow is gaining weight every day. That's good for revenue. But on the other hand, the price is going down each day, so that's bad for revenue. So we have some competing interests. Now the cost of feeding and maintaining a cow is $5.40 per day. That's also coming out of the owner's pocket. So we see that the longer the cow is kept before selling to market, the more cost we have, and so the potential for lessening our profit starts to come into play. Well, we want to know when the cow should be sold to maximize the profit, how much the cow will weigh at that time, and also what the maximum profit will be. So we'll start with a pretty simple idea, that profit is equal to revenue minus cost. Revenue is the amount of money we receive, cost is the amount of money we spend. Profit is the difference. Now the revenue is equal to the mass of the cow times the price per kilogram of the cow. So we start in this case with a 300 kilogram cow coming in at $2.70 per kilogram. Well, we're going to let X refer to the number of days that pass by. So if 1 day passes by, 6 times 1 will have a 306 kilogram cow, and 0.03 times 1 is 0.03, 270 minus 0.03 is 267. We'll have a 306 kilogram cow, and it'll be sold at 267. And for every day that goes by, letting X be the number of days, we'll add another 6 kilograms. So it'll be 300 plus 6x for the mass of the cow, and it'll be 270 minus 0.03x for the price of the beef. So we have a formula that we can call R at X. 300 plus 6x minus 270 minus 0.03x. Or sorry, times 270 minus 0.03x. Now we also have a pretty simple idea for cost. The cost to the owner of the cow is $5.40 times the number of days that go by. Well, we've just established X days go by. So the cost is 5.4x. That means that profit equaling revenue minus cost can be re-expressed as profit equaling our revenue function minus our cost function. Well, what we do here, we want to get a formula for profit, and we'd like it to be in standard form to start. So what we're going to do is distribute 300 times 2.70, 300 times negative 0.03x, 6x times 2.70, 6x times negative 0.03x, and then we still have to subtract our 5.4x. And when we collect up all our like terms, we see that we get negative 0.18x squared here. Adding 16.2x and subtracting 9x and 5.4x is like adding 1.8x, and then we have 810. So this is our profit formula, and we're looking for maximum profit, and so what we want to do is determine the vertex here. And the vertex can be determined by partial factoring. Factor out negative 0.18x from the first two terms. So factoring that out, we get x minus 10 as our second factor. Negative 0.18x times x minus 10 plus 810. Well, we can now see where our vertex is going to be. We're going to use partial factoring. We're going to let the first this first factor equal 0, and we get x equals 0. And then we're going to let the second one equal 0, and we're going to get x equals 10. So the method of partial factoring tells us that our axis of symmetry will be halfway between x equals 0 and x equals 10, which is at x equals 5. So what that means is that the cow should be sold in 5 days to maximize the profit. Now we want to know what the mass of the cow will be. Well, the mass of the cow, if we go back to what we said a while ago, is 300 plus 6x. So that's 300 plus 6x. Since we just said x equals 5, that's 300 plus 6 times 5, which is 330. So we see that the cow will weigh 330 30 kilograms when it's sold in order to maximize the profit. And finally, we're going to determine what the profit actually is. Well, this is our formula for P at X. So when we sub in a X value of 5 days go by, we sub in 5 for X, and we get 4.50 plus 810, or in other words, 814.50. And so what that means is the maximum profit for the owner of the cow is $814.50.